Good evening, guys. I'll be discussing to you some important concepts on strength reduction factors. So we will be try to review the old code, ACI and NCB, and compare them with some uh, new versions of the code. Okay. So for ACI, 1999. The strike reduction factors are as follows. So for flexure without axial loads, we are very familiar with uh, this value, which is 0.90. We've been using this for beams. And for axial tension and axial tension with flexure, normally these are uh, beams with tension forces, which is also 0.90. And when we're talking on columns, we are considering axial compression and axial compression flexure. So these are columns and beam column members. Okay, so we have 0.75 for spiral and 0.70 for tie reinforcement. So we are familiar normally with these values because we've been using this for decades now. So for members in which Fy doesn't exceed 60 ksi and with symmetric reinforcement, noting that your H minus D minus D as H, which is known as your gamma factor for columns. No? So if you know gamma for columns, so not less than 0.70, we shall be permitted to push linearly to 0.90, which is a beam, and decrease to 0, and decrease to a certain value as ppn decreases from 0.10 fc prime ag to 0. Okay, so this is the uh, point on which your value for phi decreases. Okay, so this is the value for phi up to a certain point, which is a 0 here. So the transition between the beam and the flexural, the beam and the column behavior is a straight line connecting these two points for spiral and for tide. And if you want to get the value of your phi at the transition, we have to just know the value for ppm. Okay, so if we know ppm, then we can solve the value of phi. Okay, so by simply make use of a triangle here, okay, for tide, and another triangle here for spiral. So if we do the proportioning, we will arrive with this formula, wherein your PV here is defined ultimately as 0.10 Fc prime Ag. Okay, so this is the value. But if your Fy exceeds 60 ksi, then your PV will have two values to be considered, whichever is smaller, and then what happens is that your PT will certainly be a little bit disturbed since your PT will be in the function of P. Okay, so P and T here will be still to be recalculated or manipulated so as to solve the more accurate value for your P. Okay, so the formula does not apply directly when Fy is greater than 60 psi. So that's the only thing you need to consider in using these two formula. Okay, so again, this was just derived simply by using a ratio and proportion. So for the variation of P with VPN, uh, this is your uh, basis for growth code ACI 1999. Okay, the shear torsion bearing on concrete post-tension anchorages are given here in terms of the values 0.85, 0.75, and 0.85 respectively. So for ACI 2002, the slight difference was made on the column. So these are the column numbers. Okay, column R between column, and these are the beam members. So remember now that the term for beams and the term for columns are no longer the same, but the tension control section, the compression control sections are the ones being used to make it more appropriate with the code that we are using today in terms of activity, with the ratios of activity. Case slight adjustment, so this was formerly 0.75 and this was previously 0.70. Again, this is for type and this is for span. And the variation of phi now is no longer based on VPN but rather on epsilon P and C over D. Okay, so this is for grade 6 reinforcement on pre-stress steel. So what changes when your steel is no longer grade 60? I think there's a slight change in the value of your 0.005. Okay, so for the boundary points, we know that at 0.002 we have C over dt equivalent to 3/5. Can be graphed by simply looking at this simple strain graph. So this is 0.005. Okay, so this becomes 0.008. So this is 3 over 8 of your C over dt. Okay, so this is 3. Sorry, I'm referring to this 3 over 8 of your C over dt. So this is now 0.005. So this is for tension control section. And for compression control, it's just similar. So you can get here 0.003 and 0.002. So this will become 0.005. And this is C over, so 3 over 5 of C over D. Okay, so this is a compression control, and in the transition zone, all you need to do is take again the ratio and proportion. So by ratio and proportion, we can simply get the values. Okay, so take note, it's now 0.70 and 65, so this is 70 and 65 here. So if you want to get the value of phi, somewhere in between these two words, you just make use of this triangle here, and maybe a triangle here. Okay, so this corresponds to your epsilon d. So for this, we can get another triangle here and triangle here. Okay, at epsilon. So doing the proportioning, we get this. I think this is 67, 157 to 67 epsilon t, and this is 0.48 plus 83 epsilon. So your shear and torsion bearing on concrete and post tension are a little bit different. A while ago, this is 0.85, this is 0.75. And this is, I think, around, same as 0.85. Okay, in the 1999. Okay, so these are not included in 1999 code. So that's the difference between the two codes as far as getting the few factors concerned. So I'll discuss to you some more uh, information on this as we go along discussing load combinations, etc. on my next video. Thank you very much for listening.